Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. I am now inspecting the power supply of the power supply of my desktop computer. I open everything and I try to inspect it. I check the fuse. The fuse is intact. This one here. Okay, but the primary side is dead. This is where the 15 volts come in. Okay, it goes to the primary side. The primary side comprises of many diodes, okay, solenoids to rectify the needed direct current that should be fed on the secondary side. The secondary side is actually this portion here, this one here. Okay, so whatever rectified DC voltage on the primary, it will be fed to the secondary. And on the secondary side, this one here is actually heatsink. Okay, I think this is a big diode, okay, rectifying the current that goes to the primary. So whatever the output of this, it will be fed to this, what do you call this portion here. This is also the so-called heatsink of all the, what do you call this, voltage regulators needed on the secondary side. Because there are lots of voltages on the secondary side. It could be 5 volts, 9 volts, 12 volts, or 18 volts maybe. So in here, actually, mounted on this heatsink. Okay, you see these ones? Those ones? You see these ones? Okay, those ones? Those are voltage regulators. And the output of these are actually the one coming out here. Okay? So whatever voltage on the primary, it will be paid here. So if the primary is alive, all these voltage regulators on the secondary side will also supposed to be alive. Okay, but it seems if we try to measure the output of the connectors, there is nothing except for a 1 voltage coming from the green wire, Okay, that's the green wire. And actually, this voltage here just emanates directly from the power input. The green here is actually this one here. So it seems this is the standby voltage going in. But supposed to be that voltage is 5 volts. But I only measured it as 3.5. Because at plug-in, the microprocessor should have a standby voltage of 5 volts. At plug-in. Okay? But what I measured is only 3.5 volts. So if the voltage of the microprocessor is only 3.5, okay, it will not work. The computer will not work because supposed to be the power supply of a microprocessor is actually 5 volts. At plug-in. Okay? So when you push the button on the in front of the computer, it should be alive. But the problem is, if the voltage going to the microprocessor is less than 5 volts, it will not work. So I think the problem here, there's a problem here with this green one because the output of this one at plug-in is just only 3.5 volts. And supposed to be, okay, at plug-in, the applied voltage to the microprocessor on the main board should be 5 volts. If it is not 5 volts, it will not work. Okay, that's a must. So what I will do here, since the primary is dead, but the fuse is intact, the primary is dead, of course the secondary is also dead. That's why all the voltages on the connectors going to the main circuit board is dead. So what I will do, guys, is that I will try to inspect the backside of the backside. I inspect the backside. And as my experience from troubleshooting power supplies, okay, this power supply has been for a long time, of around maybe 15 to 20 years, because this has been a computer of mine for a long time. If you try to notice it, some of these terminal connectors here, the soldered connections, this one here, okay, it seems the solder is melted, it seems it's melted. There are lots. The big terminals are actually the one carrying the high current. So since we cannot look for a dead part like right now, what I will do is that I will try to reheat all these suspected solder connections, because my suspect is that when the surge come in, okay, it's possible that there will be some what they call these terminals which give way, and we don't know which of these terminals give way. The big ones. The big ones are actually the terminals of the voltage regulators, which are what they call this producing the voltage on the connectors. So what I will do is I will try to reheat all the suspected terminal connectors which have become maybe weakened due to the power surge. And as soon as I finish reheating, I will try to check again the voltages on the secondary side. And if it's alive, that's the solution. Okay? So this type of problem, guys, is actually very hard to troubleshoot, because we don't know specifically where the location of the loose connection is. Like this one, I'm telling you, this one. Okay? It seems the solder is actually melt already. It's melted. So it's not a good connection. And if it's not a good connection, of course, the voltages emanating or the current emanating from that terminal is actually different from the supposed to be design value. It's always like that. So what will I do? I will reheat all the suspected solder connections of the power regulators. Then after that, I will try to reconnect. Then I will try to make some measurements again. Okay, this is Professor David J. De Los Reyes. As soon as I finish reheating, I will try to reconnect it and measure voltages. Okay, then I will make a video on it. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes.